Kia ora, and welcome to a lesson on Cambridge Mathematics P2 and P3, the remainder theorem. So, the remainder theorem follows on from a previous lesson on the factor theorem. So if you've not seen that video or you don't know how to do the factor theorem, I would suggest going back and looking at that now before moving on to this next topic. Okay? So, to illustrate remainder theorem, I'm going to just look at a function, f of x, that is equal to 2x cubed minus 5x squared minus 2x plus 12. And to give you an example of remainder theorem, I'm going to say if I substitute f of x with x being equal to 2 into this, then it should give me the exact same value as if I was to divide 2x cubed minus 5x squared minus 2x plus 12 by x minus 2. So the remainder that's produced here will be equal to the same value as if I substitute 2 into this. This comes from the idea that dividing by x minus 2, I can say x minus 2 is equal to 0, therefore x equals 2. That's where the 2 comes from. And let's see if that actually works. What happens when I substitute 2 into this equation here? So f of 2 is 2 lots of 2 cubed minus 5 lots of 2 squared minus 2 lots of 2 plus 12. Typed into a calculator, that gives me an answer of 4. What happens when I divide the 2x cubed minus 5x squared minus 2x plus 12 by x minus 2? Well, this comes from long division. And again, if you've not seen a lesson on that or you don't know how to do that, I'd suggest go back and look at the video now. So x minus 2 going into 2x cubed minus 5x squared minus 2x plus 12 multiplied by 2x squared gives me 2x cubed minus 4x squared, leaving me with minus x squared. So I multiplied by 2x squared to get rid of that. To get rid of minus 2x squared, I also need to bring down my minus 2x plus 12. I need to multiply x minus 2 by minus x, so that's minus x squared plus 2x. Take it away from each other, that leaves me with minus 4x plus 12. To get rid of minus 4x, I need to multiply by minus 4, so I'm going to get minus 4x plus 8. Take those two away from each other, remainder 4. So as you can see, the remainder is the same as the value of if I had substituted 2 into there. So that can be really useful if you want to quickly find what the remainder will be, and it will also be helpful later on when you look at some problem solving questions when you know the remainder when a certain thing is substituted in and you might need to find an unknown value in the original equation. Okay, there's a way we can display this so that we can say f of x as a factorizing way, we can factorize it by saying f of x is x minus 2 times 2x squared minus x minus 4. So what we did here, basically, we took out that and times by that, but then that's not fully true because we're left over with 4 at the end, so f of x is equal to this plus 4 because there's a remainder 4. And we can use this potentially to help us in some other ways. But the general concept is that if you've got a function or a polynomial, p of x, and you divide it by ax minus b, the remainder, which will look like px is equal to ax minus b qx plus r, so what we divided by the quotient that was provided plus the remainder, that r is equivalent to p b over a. Okay, that's the general rule, and it's worth seeing these general rules, but they're not the be all and end all. They're not necessarily that useful for you right now, but they might be useful later on. Okay, we're going to just have a look at some questions surrounding this so that you can have a go at yourself. Okay, the first example we're going to look at is just use the factor theorem to find the remainder when 4x cubed minus 2x squared plus 5x minus 8 is divided by x plus 1. So for this, it's really straightforward. All you have to do is say that x plus 1 is equivalent to 0, so x is minus 1, and then substitute x is minus 1 into your polynomial. So f minus 1 is equal to 4 lots of minus 1 cubed minus 2 lots of minus 1 squared plus 5 lots of minus 1 minus 8 typed into a calculator gives you the answer minus 19. Done. Okay, that's it for this question. Example 2 we're going to look at is the sort of where this is leading towards, which is a function where you've got two unknowns, a and b, in it, and how to calculate those based upon the remainder. So when that function is divided by x minus 1, the remainder is 3. When the function is divided by 3x plus 2, the remainder is minus 2. And we want to find out the value of a and the value of b. So we're going to create a simultaneous equation which we then have to solve. So let's see what we can do here. So when x is minus 1, so when x minus 1 is equal to 0, x equals 1, we get a remainder 3. So let's substitute x equals 1 into that function. So f1 is equal to 6 lots of 1 cubed plus a lots of 1 squared plus b lots of 1 minus 4, which when solved down becomes 6 plus a plus b minus 4, and that is equal to 3. Okay, because when f is 1, r equals 3, so then f1 is 3. Okay, so we can say 3 is equal to 6 plus a plus b minus 4, which becomes 1 is equal to a plus b. Okay, so that's one of our two equations which we're going to use to solve the simultaneous equation to find a and b. Okay, the other part is when f of x is divided by 3x plus 2, remainder is negative 2. So you say 3x plus 2 is equal to 0, get x equals minus 2 over 3. So when f of minus 2 over 3, when it is that, the remainder is negative 2. So therefore f of minus 2 over 3 is equal to minus 2. So let's put that into f of x. So let's see what f of minus 2 over 3 looks like. F minus 2 over 3 is equal to 6 lots of minus 2 over 3 cubed plus a minus 2 over 3 squared plus b minus 2 over 3 minus 4, and that is equivalent to minus 2. So then let's expand the right hand side. That's going to leave us with minus 48 over 27 plus 4 over 9a minus 2 over 3b minus 4. We're going to get rid of these fractions because it just makes life a bit easier. So I'm going to multiply through by 9 because minus 48 over 27 can be rewritten as minus 16 over 9. So I'm going to multiply through by 9, giving me minus 18 is equal to minus 16 plus 4a minus 6b minus 36. Then taking everything to minus 36, and then moving all the things I can to the left hand side so that I can get my two equations. That's going to give me positive 34 is equal to 4a minus 6b, which gives me my second equation for the simultaneous. I could simplify this down and divide through by 2, but it doesn't really matter. I'm now going to use my first equation, 1 equals a plus b, and this equation to find what a and b are going to be. So if 1 is equal to a plus b, then I can say that a is equal to 1 minus b. Okay? Substituting that into the 34 equals 4a gives me 34 equals 4 lots of 1 minus b minus 6b. Expand that out, gives me 4 minus 4b minus 6b, which gives me 30 is equal to minus 10b, which gives me b is equal to 3. Now that I found that b is equal to minus 3, now that I found that b is equal to minus 3, I can substitute that into my 1 equals a plus b to find a. 1 is equal to a minus 3, so 4 is equal to a, or a is equal to 4. So my solutions for a and b are minus 3 and 4. Okay, hopefully you understood that. Have a go at this question here yourself, so just pause the video and I'll give the answer to it in a second. Okay, so this question is like the first example we looked at, where you just need to say that x minus 1 is equal to 0, so x is equal to 1, and find what f1 is equal to. So that is 6 lots of 1 cubed, plus 3 lots of 1 squared, minus 5 lots of 1 plus 2, which is 6. So the remainder is 6. Okay, that's it. Let's have a look at another question. Number 2. Find the remainder when 4x cubed minus x squared minus 18x plus 1 is divided by 2x minus 1. So, same as the last one, but this time, instead of it being an x is equal to, you've got 2x, so 2x minus 1 is equal to 0. So 2x is equal to 1, x is equal to half. Once you found x is equal to half, you just find f of a half, which is 4 lots of a half cubed minus a half squared minus 18 lots of a half plus 1. Type it into a calculator, get your answer, minus 31 over 4. So the remainder is minus 31 over 4. Okay. Have a go at question 3. So just pause the video and I'll give the answer to it in a second. Okay, hopefully you had a good go at this question. It's similar to example 2, except there's no simultaneous equation that you need to go through. It's just making an equation equal to another equation at this point. So it says when x cubed minus 3x squared plus ax minus 7 is divided by x plus 2, remainder is minus 37, find the value of a. So that means x plus 2 is equal to 0, x is equal to minus 2. When I find f minus 2, it should give me the answer minus 37. Okay? So I can use this to substitute minus 2 into the original equation to calculate my a. So when I do f minus 2 into my original equation, when I put minus 2 into my original equation, I get minus 2 cubed minus 3 lots of minus 2 squared plus a lots of minus 2 minus 7, which is minus 8 minus 12 minus 2a minus 7, and that is going to equal minus 37, as I stated up above. F of minus 2 is minus 37, so I've just replaced f of minus 2 with minus 37. So let's get a's to one side and everything to the other. So that's going to give me minus 2a is equal to minus 10, which is going to give me a is equal to 5. And that's it. I found the value of a. Let's have a look at one more. This time we're going to give you a simultaneous equation question. So like example 3, and then a factorise f of x completely. See if you can do this. It's got one other thing to it that is worth discussing. So just pause the video and see if you can find the answer to this. Okay, hopefully you had a good go at that. Here's the solution. So the function f of x is ax cubed plus 7x squared plus bx minus 8, where a and b are constants, is such that 2x plus 1 is a factor, and this is key to this. The remainder when f of x is divided by x plus 1 is 7. We're going to have a look at part a first, which is just find the value of a and b. So with a simultaneous equation, we've got to substitute two values in and get two different equations so that we can then solve those two equations via substitution. We're only given one explicit piece of information, which is when I have x plus 1, which gives me x is minus 1, when I have f of minus 1, I will get the value remainder, which is 7. Okay? But the other piece of information which is really important is that 2x plus 1 is a factor. That means if I use 2x plus 1 is equal to 0, giving me x is equal negative a half, and I substitute minus a half into my function, it will give me the answer 0, because this is back to the factor theorem where if you substitute a value in and it gives you an answer of 0, then it must be a factor. Okay, so f minus a half gives the answer 0. So these are the two things I'm going to use to set up my simultaneous equation. So let's start off with minus 1 into the function. So if I look at f minus 1 and I do a minus 1 cubed plus 7 lots of minus 1 squared plus b lots of minus 1 minus 8, that should give me the answer 7, which is going to be equal to minus a plus 7 minus b minus 8, which when rearranged becomes 8 is equal to minus a minus b, or minus 8 is equal to positive a plus b. Now let's do the same thing but with minus a half now. So I'm going to put minus a half into the same polynomial. F minus a half is equal to a minus a half cubed plus 7 minus a half squared plus b minus a half minus 8, which should give me the answer 0. So if I expand the right hand side now, I get minus 1/8 a plus 7 over 4 minus half b minus 8. I'm going to multiply through by 8 to get rid of my fractions, which is going to give me 0 is equal to minus a plus 14 minus 4b minus 64, which when taken over to the other side gives me 50 is equal to minus a minus 4b, or the positive version, which is minus 50, is equal to a plus 4b. Okay, now that I've got my equation 1 and my equation 2, I can put these two together to find a and b. So I'm going to rearrange minus 8 equals a plus b to say minus 8 minus 8 minus b is equal to a, and I'm going to substitute that into equation 2, giving me minus 50 is equal to minus 8 minus b plus 4b, which is minus 50 is equal to minus 8 plus 3b, which is minus 42 is equal to 3b, so b is equal to minus 14. Substitute that back in up here, giving you minus 8 minus 14 is equal to a, so a is equal to 6. Okay, now I have a and b. I can use that for part b, which is factorise f of x completely, because I can replace my a and b with 6 and minus 14. So I can say 6, so I can say 6x cubed plus 7x squared minus 14x minus 8, and when that is divided by 2x plus 1, I'm going to get no remainder. So let's do that. 2x plus 1 into 6x cubed plus 7x squared minus 14x minus 8, multiply through by 3x squared, giving me 6x cubed plus 3x squared, take them away, giving me 4x squared minus 14x minus 8, multiply through by 2x, giving me 4x squared plus 2x, take it away, giving me minus 16x minus 8, multiply through by minus 8, giving me minus 16x minus 8, take them away, giving me 0 remainder. So my factorisation can look like 2x plus 1, 3x squared plus 2x minus 8, and then I need to factorise that second bracket down again because it's quadratic, which will give me 3x and x, as well as minus 4 plus 2. That answers B. Factorise f of x completely. Hopefully you got that. It was a bit of a longer one, a bit more tricky, but putting it all together now. Good luck with the questions, or the rest of your questions, and I'll speak to you again soon.